math.
This just makes my head hurt now.
Huh? All right, guys, I'm recording just because I'm going to go through and do all of these. I'm going to skip number 1 unless anyone would like to see how to do number 1.
No.
Okay. I'm going to jump straight to number 2. I'm just going to start doing the problems on the board to show you guys how to do them, okay?
For number 1, do we have to screenshot the Desmos or?
No, I just need the answer.
Okay.
Okay. I'm going to do 2a. Y equals 3x minus 5, 2x plus 2y, no, opposite, but whatever, equals 6.
We can't really see your board.
Thank you, Kiana. There we go. Okay, we're solving with substitution. So our first goal in substitution, we need to isolate a variable. Who's all that noise? Kainoa, could you please mute?
Yeah, sure.
No, can you hit the mute button for us?
Yeah, thanks, Nico.
Number 1, isolate a variable. Number 2, substitute it. Okay. On 2a, y is already isolated. So we can skip number 1. We don't need to isolate it. We just need to substitute it. So if we know that y equals 3x minus 5, we can replace this y with 3x minus 5 and solve for x. So we get 2x plus 2 times 3x minus 5 equals 6. By the way, this one's simple, but the next two have something in them that could trip you guys up that I want to show you. So please stick around. 2x plus 2 times 3x minus 5 equals 6. 2 times 3x is 6x. 2 times negative 5 is negative 10. So we get 2x plus 6x minus 10 equals 6. We can now combine our like terms. 8x minus 10 equals 6. Add 10 to both sides. 8x equals 16. And then divide by 8 on both sides to get x equals 2. Max, I don't mind. You just need the point.
Reggie, I'm doing this in my book. Do I need to take a picture for you?
Yes, please. Well,
Oh.
not for the practice quiz, but for
not for the practice.
Yeah.
Okay, good.
Yeah, not for the practice. I want you to have the correct work, but I'm not grading it, okay? If you would like me to check your work, I don't mind if you take a picture and send it to me. I'm just not requiring it.
Wait, what was the step that you just did?
What?
I'm on 2A, Margot. Did you ask which step I just did?
Yeah.
Okay, can you see my board?
Yeah.
So number 1 is isolate a variable, but I can skip that because y is already isolated. So now I'm going to substitute y, what y equals, which is 3x minus 5, into y in the other equation. So
What
I
was
get
the last step that you did?
I divided by 8.
Okay, thank you.
Sorry, it's getting really small down there, yeah. So I solved for x. I got 2x plus 2 times 3x minus 5 equals 6. Distribute the 2 to get 2x plus 6x minus 10 equals 6. Combine the 2x and 6x into 8x. 8x minus 10 equals 6. Add 10 to both sides. 8x equals 16. Divide by 8. X equals 2. So now I have half my answer, which is x equals 2. I'm going to erase this now unless anyone needs me to leave it up. So I've got x equals 2. That's half my answer. Now to find out y, I just need to plug in 2 for an x. I'll do the first one. Y equals 3 times 2 minus 5. Y equals 6 minus 5. Y equals 1. Now to check my work, so those are my answers. Y equals 1, x equals 2. To check my work, I can just plug those values into the other equation and make sure it's a true statement. So it is 2 times 2 plus 2 times 1 equals 6? Yes, it does. That's 4 plus 2 equals 6. Means I did it correctly. Does anyone have any questions on that one?
Oh my gosh. Okay. I get the elimination one.
Oh, nice. That's the one that we've spent less time on. So well
But
done.
the substitution one, I still am kind of confused about.
Okay.
Because it seems so much easier to just do like elimination or graphing. Substitution is the one that seems hard to me.
So interestingly enough, substitution is the one that seems easy to me. But the other ones seem hard. So can you say which part you're getting tripped up on, Oliver?
Well, like it's starting it because I have these equations, right?
Mhm.
But then I don't know what to do with them. You
Okay,
know?
no worries. So did you see how I just solved this first one?
No, I got kicked off the meeting.
No worries. You want to watch me solve it?
Can you solve the next one,
The second one?
the second one, and then I'll
Sure.
try to follow along with that.
Sure. Sounds good. I'm going to do it right now, okay? So the second one is x equals 15 minus y, and 5y minus 5x equals 5. Okay, so my first step in solving with substitution is to isolate a variable. In this case, is a variable already isolated, Oliver?
Yes, the x.
Yes, the x, exactly. So I can skip that step. So now if I know that x equals 15 minus y, then I can replace my x in the other equation with 15 minus y. Okay? And that makes it so now the other equation only has y's and no x's, so I can now solve for y. So I would write that like this. 5y minus 5 times what I know x equals, which is 15 minus y, right? Equals 5. You see how I got to there, Oliver?
Yeah.
So I get 5y minus 15 times, or minus 5 times 15 minus y equals 5. Okay, so everyone, this is important, and I want you guys to not miss this, okay? I don't want this to trip you guys up. I've gotten this far. 5y minus 5 times 15 minus y equals 5. This is 2b, by the way. To get there, I substituted what x equals, 15 minus y, in for x in the other equation. So this is where x was, the 15 minus y. So the key that I don't want you guys to miss is when you're now multiplying to distribute this negative 5 into the parentheses, you're multiplying by negative 5 because it's 5 minus 5. Okay? So what that's going to look like is you get negative 5 times 15 equals negative 75. And now you get negative 5 times negative y. That's going to be positive 5y. Okay? If you distribute this as a positive 5, you're going to get negative 5y. You're going to get 5y minus 5y. The y is going to disappear. You have to distribute this as a negative 5. It's a negative 5. Does that make sense?
Yeah.
Wait, so
Okay.
what's negative 5 times negative y? It's
Neg-
positive.
It's positive 5y.
Okay.
Because whenever you see negative y or minus y or plus y, you can think about it as minus 1y
So it would be negative 5
times negative
times
1y.
negative 1y, and a negative times a negative is a
It's
positive.
positive, exactly. So then you get 10y minus 75 equals 5.
Wait, what? Wait, where did the 10y come from?
Because I had 5y at the start, right?
Yeah.
And I get, so when I distribute my negative 5, I get 5y minus 75 plus 5y, right?
Oh, and then use like
and then I can exactly combine the like terms. So I combine my 5y with my 5y to get 10y. I saw a question. Let me check that. No, it's not multiplication, Aiden. It's 5y minus 75 plus 5y equals 5. So when I get 10y minus 75 equals 5, I can now add 75 to both sides. No worries, Aiden. And then I get 10y equals 80, since I added 75 to both sides. So I have 10y equals 80. I can divide by 10. I'm running out of space. But 80 divided by 10 is 8, and 10y divided by 10 is y. So y equals 8. I'm going to erase this unless someone wants me to leave it up right now. So I wrote y equals 8 off to the side. That's how I like to do it. Just keep that over there. So now I know y equals 8. So I can just plug in 8 for y to solve for x. I'm going to do the easier one because less multiplication, the top one. X equals 15 minus y, which is 8. 15 minus 8 is 7. X equals 7. Now, if I want to confirm I did it correctly, I plug my x and y values into the other equation and see if it makes a true statement. Does 5 times y, which is 8, minus 5 times x, which is 7, equal 5? That would be 40 minus 35 equals 5. This is a true statement. Therefore, my answers are correct. That guy make sense, Oliver?
Yeah, it does. Okay, thank you.
You want me to go through the next one?
Yeah.
I'm going to, whether you want me to or not. Okay, so 2x minus 2y equals 12. 3x plus y equals 16. So in this case, the variable is, there is no isolated variable at the start. So I need to do number 1. Oliver, do you know how I'd isolate the variable? I'm not picking on you. If you don't want to answer, it's okay.
Oh, sorry. I was trying to write the answer down into the doc. So
No
to isolate the variable,
Mhm.
I would divide 2x by 2 to get x alone,
But
and
you
then
have,
divide below.
so if you're going to divide x by 2, you have to divide everything by 2, which is you can do. But just remember, if you're going to divide x by 2, you have to divide everything in the equation by 2 to keep it true, okay?
So then you get x minus y equals 6.
Exactly. And then what do?
And then you plug negative y equals 6. Wait,
Not yet.
y equals 6.
So, wait. So I've got x minus y equals 6. I still want to isolate.
Oh, and then you can subtract y.
I got to
Or
add
add
it.
y to the negative.
Exactly.
And
Then I get x equals y plus 6, right? Right?
yeah.
Exactly.
Yeah.
That's perfect, Oliver. So I've got x equals y plus 6. I'm just going to write that over here. It's the same as that equation, okay? Now, hold on. Just to show another way you could have done it is, since we have 3x plus y equals 16, if you subtract 3x from both sides, just one second. Let me just finish this. If you subtract 3x from both sides, you get y equals 16 minus 3x. It's another way to isolate. They both work. Kanan, yes.
For question number 4, Do you have to show your work on how you got to this? It's like, what linear systems can you find that go through the line 2, 2? How do you, like, or can you just find, like, if you know, like, 2 easy ones, can you just put them there?
Yeah, that works.
Okay.
Cool. Okay, so back to our equation. Oliver, I'm going to use yours. X equals y plus 6. So we've done number 1. We've isolated x. We know that x equals y plus 6. So I can now plug that in for this x right here in the other equation. So I'll have 3 times y plus 6 plus y equals 16. I now have to distribute my 3 to the y plus 6. I get 3y plus 18 plus y equals 16. I can combine these like terms to get 4y plus 18 equals 16. I can subtract 18 from both sides to get 4y equals -2. Lastly, I will divide by 4. 4y over 4 is y. -2 over 4 is -0.5. So now I know, I'm going to erase this unless anyone wants me to leave it up. So now I know y equals -0.5. So I'm just going to plug it back into the easiest one. I think the easiest one is the one Oliver made. X equals y plus 6. X equals 0.5 plus 6. Negative. Sorry. X equals -0.5 plus 6. -0.5 plus 6 is 5.5. X equals 5.5. So now, lastly, I'm going to check my work by plugging it into the other equation. 3 times 5.5 plus -0.5, exactly, plus -0.5 equals 16. Let's find out if that's a true statement. 3 times 5.5 is 16.5 plus -0.5 or minus 0.5 equals 16. Correct. Those explanations help at all, Oliver? That help?
Reggie?
Yeah.
Right on. Who was that?
Wait. Hold up 1 sec. For what's if it's one of them's a positive for the like the elimination one, if one is a positive and one of them's a negative, do you add them together?
Yes. Right? Because what would like -4 plus +4 be?
Plus 0.
Exactly. So yeah, when one's a negative and one's a positive, you add them. When they're both positive or both negative, you subtract them.
Because I got one that's for the 4C, it's like 12. It's like 4y plus 6x equals 12 and -3y plus 8x equals -9. My answers are the same. Like they both add up to 36.
I'll try and work it out in just a second, okay?
Okay.
Someone else had a question for me and I missed it. If anyone has a question, let me know. Okay. All right, I'm going to jump on to number 4, Kainoa. Which one are you on number 4 or number 3? Sorry.
For the elimination one, it's C.
Okay, I'll just jump to that one and then go back and do AB, okay?
Okay.
So we get 4y plus 6x equals 12 and -3y plus 8x equals -9. Okay.
I made y equal 12. Or I know I said 12y. And
Yeah.
12y.
That's what I would have done too. So this is the hardest one because on the first one, you don't need to multiply either equation. On the second one, you need to multiply one of them. On the last one, you need to multiply both. So the way I would do it is the way that Kainoa did it. He wants to get a positive 12y on the top and a negative 12y on the bottom. Is that correct?
I did positive 12y on both of them. So I multiplied the second one by -4.
Okay, I'll do it that way. So he's going to make them both positive 12y. So to get the top as a positive 12y, you multiply it by 3, which is going to give us 12y plus 18x equals 36, right?
Mm-hmm.
And then to get the bottom as positive 12y, you have to multiply it by -4, right?
Yep.
So then you get positive 12y minus 32x, right?
Mm-hmm.
Equals 36. So now you subtract. 12y minus 12y is
0.
0. 18x minus 32x is, or minus negative 32x.
40? No, 50.
Plus 50x. 36 minus 36 equals 0.
Yeah.
Wait, 18 minus 32 is not 50.
18 minus negative 32.
Oh.
So what would it be?
So I'm going to just get rid of that. So what times 50 equals 0?
0.
0. So what does x equal?
0.
0.
So that means that y equals 3.
Exactly.
Okay.
So then I'm going to plug my 0 in. 4y plus 6 times 0 equals 12. 6 times 0 is just 0. So 4y equals 12. Divide by 4. Y equals 3.
So is it 3 and 0?
Yep.
Reggie, don't erase it yet.
Sure.
Okay.
I'm happy to go over it from the start too.
Wait, was that B or A?
Let's see.
Wait, why?
I jumped to C because Kainoa was working on it and had a question.
Oh.
If we finish,
I'll go back and do A and B.
Reggie, if we finish, are we on lunch break or should we stay here?
No, you're good. I have no more announcements.
Okay, thank you.
Yeah, no problem.
Thank you, Reggie.
So Kainoa. Oh, he's gone. Whatever. He knows. Basically, I was just going to tell him the test tomorrow is just basically this, but with different questions.
Wait, Reggie, I have a question.
Uh-huh.
If two lines are identical, they have infinite solutions, right?
Yes.
And I don't get 4.
Okay, I'm done.
I probably get 4, but using any method you like, find a linear system with a solution of 2, 2.
Yeah.
Wait, Reggie, we have to do the Empower thing today?
Aiden, this is not due. This is just to help prep you for the quiz, but the quiz tomorrow is going to be about this long.
Okay.
And it'll be due at the end of the day, although my goal is to make it so you can get through it in the class, okay?
Okay.
But if you don't finish, I'm not grading this practice.
Wait, how come problem 7 is already solved? And so is problem 8.
What?
And also problem 9 and 10.
Oh, that's your answer key.
What?
That's
That's
the
the
answer key.
answers, Aiden.
Oh,
That's just so you can check your answers. So if you're working on this afternoon and I'm not around and you want to make sure you did it right, you can just check your answers. Got it?
oh wait, so they're the same problems. That's just right below. That's the answer sheet.
Yeah, exactly.
Wait, Reggie, for A, you don't have to do anything, right? Can you just subtract already because 2x and 2x are the same?
4A.
Yeah.
Why don't I just jump to 4A?
I mean,
The answer is
3A.
yes, but let me show it. 3A.
Thank you,
Yeah, let me
Reggie.
just jump to it. Yeah, no problem. I'm going to erase this guy, okay?
Okay.
I'm happy to do 3C again. Nico, can you just read 3A off to me?
2x plus 6y equals 14. 2x plus 2y equals 12.
Okay, so remember, our first goal is to multiply or divide until the number in front of the variable in both equations is the same. It can also be a negative and a positive. I'm not going to write that.
Wait, it can?
Yes. I'll show you how to do that in a sec. Okay, Nico? Add or subtract to eliminate a variable. Okay, so Nico, you are correct that since the 2x is already in both equations, I don't need to multiply or divide. Step one's done. Since they're both positive, do I add or subtract, Nico?
Subtract?
Exactly. If one was negative, if it was 2x and negative 2x, I could add them. Add the two equations, okay?
Okay.
Because 2x plus negative 2x is what?
2x plus negative 2x is 0.
Exactly. So
Wait,
I'm
no,
gonna
it's not. Oh,
Yeah.
yeah, it is.
So I'm going to subtract the bottom equation from the top equation because my goal, this is elimination. My goal is to eliminate the x. 2x minus 2x equals 0. And just cancel that bad boy out. 6y minus 2y equals 4y. And 14 minus 12 equals 2. Now I'm going to divide by 4. On both sides, I'm going to get y equals 0.5. Right?
Yeah.
Now I'm going to write that over here. We're going to erase. Now I can just plug 0.5 in for y in either equation. We'll do the top one. 2x plus 6 times 0.5 equals 14. 2x plus, this is 3, equals 14. It's a terrible 4. I'm now going to subtract 3 from both sides. 2x equals 11. Divide by 2. That's not a number. X equals 11 divided by 2, or 5.5. Okay. Now to check my work, what do I do?
Substitute.
Both x and y in to the other equation. So 2 times 5.5 plus 2 times 0.5 should equal 12. 2 times 5.5 is 11, plus 2 times 0.5 is 1. 11 plus 1 does, in fact, equal 12. I did it correctly.
Wait, how did you find x?
No worries. I'm going to start over from the beginning, okay, Margot?
Can you do
Okay.
2?
You mean the substitution one?
The what?
What do you mean 2?
3b.
Yeah, I'll do 3b in a second. But I'm going to go over this one again. Okay. So at the start, I've got 2x plus 6y equals 14, and 2x plus 2y equals 12. Are you with me, Margot?
Yeah.
So since I already have 2 x's in both equations, I can skip step 1. I don't need to multiply or divide either one to make the numbers in front of variables equivalent. I already have. I have 2x and 2x. And my goal is to eliminate a variable in one of the equations so I can solve for the other. Oh, you were wondering how I got x. Sorry, this is how I got y. Did you follow how I got y, or do you want me to keep going?
Yeah, I got that.
Okay. So y equals 0.5, right?
Yeah. Wait, no.
No worries. Okay.
Wait,
so
yes.
You got, so I subtracted, right? The bottom equation from the top equation. So I got 2x
Yeah.
minus 2x, that cancels out. 6y minus 2y is 4y.
Yeah, just for the last step, I divided 4y by 2 and got 1. I forgot to do it again, like by 4. So
Oh, got it.
2.
So yeah, you divide by 4, and then you get y equals 0.5. Then to get x, I just plug in 0.5 for y in either equation and solve for x. I'll do the bottom one. So I get 2x plus 2 times, let's write this less messy, 2x plus 2 times 0.5 equals 12. 2 times 0.5 is 1. So I get 2x plus 1 equals 12. I now subtract 1 from both sides to get 2x equals 11. I now divide by 2 to get x equals 5.5. Did you see how I did that?
Oh, okay. Thank you.
Yeah, no problem. Okay, I'm going to now do 3b. Everyone okay with me erasing this?
Yes.
Okay. Okay. Can someone read me 3b?
3x minus 6y equals 18. 6x minus 4y equals 12.
Okay, so the first thing I need to do is multiply or divide until the number in front of the variable in both equations is the same. Because right now I have 3x and 6x, and I have negative 6y and negative 4y. So neither of those are equivalent, negative 6 and negative 4, or 3 and 6. So the easiest way for me to make the number in front of two variables in each equation is the same is I'm just going to multiply the top equation by 2 to turn it into 6x. So I'm going to get 2 times 3x is 6x minus 2 times 6y, so minus 12y, equals 2 times 18, which is 36. So I get 6x minus 12y equals 36. I can now
Reggie, oh, my bad.
No worries.
I was just gonna say, do I have to write anything on the doc? I did everything on paper.
So no, since you're not turning in this practice quiz, you don't need to write anything on the doc. It's just for you. Tomorrow with the quiz, the actual one, you can do the whole thing on paper, but I want you to take pictures and attach it somehow. Okay.
Wait,
Like put it in
Reggie.
the doc or something.
Do you add or
Yeah.
subtract here?
So I'm going to subtract here, and let me tell you why. Okay, Nico? So I multiplied by 2 to get 6x minus 12y equals 36. I have a 6x in both equations, so I don't need to do anything to my bottom one. I'm just going to bring it down here. 6x minus 4y equals 12. So remember, my goal in elimination is to eliminate one variable. That's the whole point. So to know whether or not I subtract or add, the question is, would subtracting or adding get rid of one variable? And the way you can tell is anytime the number in front of the variable is the same, in this case it's 6 in both, you subtract, because 6x minus 6x is 0. If one is positive and one is negative, a 6x and a negative 6x, you can add them, because 6x plus negative 6x is 0. So my goal is just to eliminate one. So I'm going to subtract them here. So I get 6x minus 6x. That just equals 0. So it cancels out. Then I get negative 12y minus negative 4y. Negative 12y minus negative 4y is like adding 4y. So it's just negative 8y. So then I have to subtract 12 from 36. 36 minus 12 equals 24. So I'm just going to get rid of the 0. The zeros don't matter. Negative 8y equals 24. I can now divide by negative 8. And I get y equals negative 3. Okay? So now I know that y equals negative 3. I'm going to write that over there. There's half my answer. Everyone okay with me erasing this?
Mm-hmm.
So now let's just plug negative 3 into either of these equations. 6x minus 4 times negative 3 equals 12. Now, I need to multiply this right here. But remember, this is very important. You are not multiplying 4 times -3. You are multiplying -4 times -3 because it's -4. So -4 times -3 is +12. So I get 6x plus 12 equals 12. Now, this is the same situation Kainoa saw in the other one. If I subtract 12 from both sides, I get 6x equals 0. What times 6 equals 0?
0.
0. That means x equals 0. Now, you may say, hey, that's weird. I didn't think I'd get 0. So we can always check our answer. How do we check?
Substituting.
Substitute -3 and 0 in for x and y and see if it's a true statement. I'm going to erase this guy. So 3 times 0 minus 6 times -3 should equal 18. 3 times 0 is just 0. -6 times -3 does, in fact, equal 18. So I got a true statement, so I did it correctly. Anyone want to see that one again?
No.
Okay. By the way, I am recording this. If you guys want to check it later, since it's going to end up being like a 45-minute video, it's going to take me a couple hours to get it up on YouTube. But once I'm done with that, I'm just going to load it up as a comment on today's class event, and you can come check these later.
Do we have to submit this to you?
No.
Okay.
I'll
Thank
give you
you.
the test tomorrow on ManageBack and to submit, but this is just for you guys. You don't have to turn them in, okay?
Okay. Thank you, Reggie.
Yeah, no problem. I'm going to do 4C now. I did it earlier. I'm going to do it again. Unless anyone has a specific question, because I know there's only 10 minutes left. Or 3C, sorry. If you guys want to just quickly know the answers to 4, 4, tons of answers. 5, if 2 lines are parallel, they have 0 solutions. If 2 lines are identical, they have infinite solutions. I'm just giving you guys those explanations instead of giving you equations that turn that out because we don't have enough time. I don't want to make this unit any harder on you guys than it needs to be. So 3C, 4y plus 6x equals 12. I'm going to do this differently than Kainoa did it this time. -3y plus 8x equals -9. So what Kainoa did was Kainoa wanted to make the 4y into 12y and the -3y also into 12y so that they were equivalent. So to do that, he multiplied the top equation by 3 and the bottom one by -4. This time, I'm going to multiply the top by 3 and the bottom by +4, which is going to give me 12y and -12y. So the top, it works either way. It's just whichever one works better for your brain. So 3 times 4y is 12y. 3 times 6x is 18x. And 3 times 12 is 36. So I get 12y plus 18x equals 36. Now I'm going to multiply the bottom by +4. 4 times -3y is -12y. 4 times +8x is 32x. And 4 times -9 is -36. So now, since I have a +12y and a -12y, and my goal is to eliminate, I'm going to add them together so that 12y and -12y cancel out. So I get 12y plus -12y, which is 0. So it cancels out. It's gone. Then I get 18x plus 32x, which is going to be 50x. And I get 36 plus -36, which is 0. So now I get 50x equals 0. That means that x has to equal 0. That makes sense? Cool. So now I'm going to plug my 0 in. I'll do it into this bottom one. -3y plus 8 times 0 equals -9. 8 times 0 is 0, so I get -3y equals -9. Divide by -3, and y equals +3. So x equals 0, y equals 3. I'm going to now check it by plugging it into my other equation. I'm going to erase this.
On the answer key, it says y equals -3.
For this one,
I'm pretty sure.
there's another one that's -3, 0. I might have mixed them up.
There's two that say 0 and -3.
Really?
Yeah. B says x equals 0, y equals -3, and C also says that.
I messed up. One of them is +3, which is this
Okay.
one. My mistake. I'm going to try and... God, I hate when I do that. Sorry, guys. Because I want to fix it for you guys, but now half the class is gone. Yep, that's correct. I made a mistake. Good eye, Margot. I'm going to message everyone and somehow let them know. I'll figure out how I'm going to do it.
Thank you.
My bad.
Goodbye.
How you feel about this, Kiana?
Me, pretty okay. Yeah, it's fine. I think I have it just fine. It could be better, but because I still have to double check and look back sometimes. But
that's okay. There's nothing wrong with needing to double check. This is a long unit that we're doing in 6 hours, so
yeah.
So I don't expect any of you to be experts in 6 hours.
Yeah, probably could have done better with more time, but I'm pretty fine with what I do know.
All right, thank you, Reggie. I just finished.
Right on, Aiden. Okay, take care, Kiana. Aiden, you feel okay about this quiz?
Yeah.
Same with you, Margot and Tarak.
Bye.
Take care, guys. Enjoy your lunch.
Okay.
Tarak, you hanging out, or did you walk away and just leave your thing on?